make sure my family drives through, because Ellie is I've taught her how to do like the ASB posters. So she's going to be super impressed. I'm not even going to tell her ahead of time what they are. I'm like, you just have to go see. So I was going to show the video, and then I'm like, no, everybody needs to come and be surprised, because they are really super amazing. Okay. Let's grab, I need to grab really quick a unit circle to put in here, because we're going to need it here in just a second. So let me find that really fast. Or not, it's going to be slow. It is under, now it's just being stinky. There we go. I can't spell today. Unit circle. And I want this one. Okay, did it pop up there? No. Where did it go? So it's not coming. Okay, let me grab one from up here. This machine's being stinky today. And now there's like nothing. Oh, there it is. It came up. Okay, we're good to go now. All right, so we are going to verify that each x value is a solution to the equation. So basically what they're saying there is hey, pop those values in there and solve it and make sure both sides come out to be the same thing. Okay, that's what they mean by it. Our goal is ultimately to be able to solve an equation that has trig in it. Probably today is leading into probably Monday is probably the most important lesson outside of just understanding your unit circle for what you need to understand to just walk in the door next year. Okay, so I'm glad we've gotten this far. Last year's group, I had to teach it to them at the beginning of the year this year before they even started the calculus. You guys are like light years ahead of where they're at. All right. So all I'm going to do is literally plop this guy in there. Okay, so I'm going to say 2 sine of 7 pi over 6 plus 1. I'm going to see, and I'm going to put a little question mark there because I don't know that that equals 0. I'm testing to see if that's true or false, basically. All right, so here is where our good old unit circle comes in. Let's see if I got it. Oh, there it is. Okay, so I'm going to find 7 pi over 6. Can you guys tell me what quadrant is 7 pi over 6 in? What quadrant is 7 pi over 6 in, everybody? You guys can just tell me out loud in the room. Yep, good job. I'm waiting on my chat. Okay, seeing a lot of quadrant 3s. That's awesome. Okay, so we're looking right here. Sine, it's been a while, but sine is our y coordinate, right? So I'm going to plop my y coordinate in there. So 2 times negative 1/2 plus 1. We're still checking to see if that equals 0. Let's see, 2's cancel. So negative 1 plus 1. Does it equal 0? Are we good? Is it true or false? What do we think? Good. True. I'm waiting on my chat. What does the chat think? What do you guys think? Is that a true statement or a false statement? All right, we got a lot of trues going on. So this one actually works. So I would say it's true, or the word yes, that one is a solution. Okay. So we know that that one worked. Now we're going to test 5 pi over 3 and see if it worked. So I'm going to change here. So 2 times sine, because notice they gave us 2 x's there, right? 5 pi over 3 plus 1 equals 1. All right. What quadrant is 5 pi over 3 in? Tell me in the chat what quadrant is 5 pi over 3 in. What do we see it in? What do you guys think? Good. Okay. It is, in fact, in 4. Good job. Okay. Is sine the x coordinate or the y coordinate? Good. Waiting on my delayed chat. There we go. Okay, good job. Y coordinate. So I'm going to grab the y coordinate, negative square root of 2 over 2. So 2 times negative square root of 2 over 2 plus 1. I am testing to see if that equals 0. Our favorite thing to do, cancel. Ooh, true statement or false statement? What do you guys think? True or false right there? Negative square root of 2 plus 1 equals 0. What do you guys think in the room? Yeah, good. All right, definitely a false statement. So in this one, we would see either it's false or no. Okay. The ones that WebAssign was doing, they were just bizarre. And the way they're having you fill in the blanks and things was weird. So I decided we'll just wait until we can do an assignment out of, Delta Math. Delta Math didn't have these. All right, I want to show you one like example too, because of the squared thing on it. It makes it a little bit weird, okay? And this is just a property that you have to get used to when it comes time for next year, because we do see a sign squared in calculus quite a bit. So writing it here on the sign means the whole function is squared. Sometimes that doesn't work for us when what is going on? Come on. When we're calculating arithmetic. It is just being weird. It says it's Friday. It doesn't want to work. Yeah, I know. Okay, well, give me a few minutes to get through the lesson. All right, so I'm going to rewrite it as sine of 2x squared minus 2, and we're checking to see if that, or we haven't substituted anything in yet. We're not checking to see if it equals 0 yet. Okay. So, it's like there's a delay between screens right now. They're literally sitting right next to each other. Okay, so that's just another way that we can write it. So that basically means I can square whatever I get in there. So it's another way to write the sine squared, okay? Now I'm going to go ahead and I'm going to plug in my pi over 8. So I've got 4 times sine of 2 pi over 8 squared minus 2. Now I'm checking to see if that is a true statement, okay? I know pi over 8 is not on my unit circle, but I notice that I can cancel it with the 2. So it becomes 4 sine pi over 4 squared minus 2. We're still checking to see, does that equal 0? All right. Look on your unit circles. I want to know, what is the sign of pi over 4? What is the actual value that's on the sign there? You guys tell me in the chat. What do you guys think here in the room? I'll put it up there again. Maybe. There it is. What do you guys think? Sine of pi over 2. Nobody? There we go. Good. All right, I'm seeing lots of square root of 2 over 2's. Hopefully you've got that pattern down now, right? We like the over 4s because it's the same coordinate in the x and y. It's easy. You just have to figure out which like if it's positive or negative in front. The good news is in AP Calc, we usually see it's usually quadrant 1 and quadrant angles. We don't work with a whole lot else other than that. So sometimes, but not often. All right, so I have 4 square root of 2 over 2 squared minus 2. We're checking to see, does that equal 0? I'm going to have to remove my work up here because I wrote too big. All right, so I'm going to square what's inside of that. So that means that the square root of 2 squared is just 2. 2 squared in the denominator is 4. Minus 2 equals 0. I'm still testing this. What happens with my 4s? What do we think in the chat? When I ask the question, you guys can all answer it here in the classroom, okay? All right, I'm seeing a lot of, yeah, we get to cancel. It's like our favorite thing, right? All right, true statement or false statement? Minus 2 equals 0. True or false? Good job, much better here in the classroom. All right, lots of truths. Good job, everybody. Okay, so this is a true, so this one is definitely a solution to that equation, okay? So now we're going to try it again with with 3 pi over 8. Okay, I'm going to do my work kind of over to the side here. So I've got 4 times the sine of 2 times 3 pi over 8 squared minus 2 equals 0. Okay, first thing I would do is probably put, oh my goodness. First thing I need to do is plug in my machine. It's where you turn Google Meet on and it like dies immediately. There we go. Okay, so first thing I'm going to do is take and simplify that, right? So sine of 3 pi over 4 squared minus 2 equals 0. Okay, once you're looking on your unit circles, I'm looking for the sine of 3 pi over 4. So what is the sine of 3 pi over 4, everybody? Nice work. It's the best call response I've had all year. Waiting for the chat. What do you guys think the sign of square or 3 pi over 4 is? So you all get to experience what I do at home now. Okay, square root of 2 over 2. So we've got 4. Square root of 2 over 2 squared minus 2 equals 0. 4, we're going to square that again, would be 2 over 4, right? Looking pretty good, isn't it? So true or false? What do we think? I didn't put my little question mark over the top this time, did I? True or false? What do we think, everybody? I'm waiting for my chat. What's my chat thinking? All right, I'm seeing a lot of true, so this one is true as well. Okay. All right. So we're going to take a baby step into what we're going to hit on Monday. Okay. Like I said, once we're done with this piece, we'll do some time for you, give you some time to get some work done. We've done this before. Okay. So this is kind of a review. It says to go in degrees. I happen to have radians, so I'm just going to say let's do this in radians. Okay. So let's go 0 to 2 pi. Okay. And remember the bracket versus the parentheses. The bracket means that it is included, the 0 is included as an answer, whereas the 2 pi is not included. It just means we're going to go all the way up to 2 pi, but not include the 2 pi. Okay. All right. So basically what we're doing is we're looking at reversing and finding the angle measure. So, and this isn't the arc. So notice the word arc is not in there. Okay. So that means I can use all my quadrants. There should almost always be 2 answers to everything. There's a few exceptions to that rule, but there should be 2 answers to everything. All right, so I'm looking for my x value. When the cosine is negative square root of 3 over 2. So is cosine the x value or the y value? I'm gonna wait for my chat. Come on, chat. Okay, so I'm going to walk around my unit circle. We've done this before. We're going to walk around our unit circle until we find the x value every time the x value is negative square root of 3 over 2. Would have made more sense for me to put like a theta in there, huh? All right, happened to just be typed as an x. So I'm going to go negative square root of 3 over 2. Let's take a walk around this unit circle and look. I'm looking at all my x values. Oh, here's one of them, so I get to use 5 pi over 6. Oh, here's another one, so I know I'm going to use 7 pi over 6. So my 2 answers are 5 pi over 6 and 7 pi over 6. We've done this before, right? We did it in a slightly different context, but we've seen this before. Okay. All right. It gets uglier than that, though, right? This is important enough that it's in 2 or 3 lessons, right, that we've done this year. Okay, so now we've got tangent of -1. So remember, tangent is what divided by what in terms of sine and cosine? Good. Okay, I'm waiting on my chat. What is tangent in terms of sine and cosine? Okay, got a few of you. I want to see everybody. Unless you're sitting in the room, I want to see everybody in the chat. It's part of your grade. Okay, so I'm seeing sines divided by cosines. So what that means is that my sine divided by my cosine have to reduce to -1. That means they need to be the same value on the top and the bottom, okay? But with opposite signs. So if I go to my unit circle, I think we've explained this a few times before, I'm going to look for values that have the same x and y, but with opposite signs. Hopefully we know that that happens at the over 4s, right? This one, same sign, can't use it, right? This one, opposite signs, I can use that one. So I'm going to use 3 pi over 4. Oh, same signs, can't use that one, right? This one here, ooh, opposite signs. I get to use 7 pi over 4. So 3 pi over 4 and 7 pi over 4 would be my solutions for my x. So again, what just happened was that I knew that if I write square root of 2 over 2 divided by square root of 2 over 2, that would reduce to 1. I need one of them to be negative, so I don't know if it's the one on the top or the one on the bottom, so I'm going to grab both of them. Okay. They have to have opposite signs. Okay, let's take a look at, so this is the same thing, but it's officially saying radians. We're gonna keep going with radians. All right, let's see if you guys can do this one on your own. Okay, so I want you to walk around the unit circle and just write it down. You don't need to put it in the chat yet. Walk around the unit circle, find the two locations where sine is equal to square root of 3 over 2. And just write it down on your paper. All right. Okay, tell me in the chat or in the room here, what did we get for those two values? What are we thinking? Be brave. Nobody? You guys can do this. Pi over 3 and 2 pi over 3. I'm seeing a lot of. Everybody in the room is quiet. All right. So let's check that out because I want to make sure that we are all understanding that. So we're looking everywhere on the unit circle where we had square root of 3 over 2 in the y value. So I'm going to find all my y values. Here's one of them, and it's got to be positive. There's the other one. So I'm agreeing with pi over 3 and 2 pi over 3. So pi over 3 and 2 pi over 3. Perfect. All right, secant's a little bit weird. Okay, so secant is one of these ones where I kind of have to build up to what's on my unit circle. Okay. All right, so what is secant the reciprocal of? Can you tell me that in the chat? What's secant the reciprocal of? What do you guys think here in the room? Good. Okay, so secant's the reciprocal of cosine. That means that I know there's always a 1 in the denominator, right? So that means I'm going to flip the secant on the right side. So that gets to be negative 1 over square root of 2. And this becomes cosine of x. Unfortunately, that is not on my unit circle, right? But hopefully you recognize that I have to rationalize it. And you should be getting close to seeing that pattern that negative 1 over square root of 2 is negative square root of 2 over 2. They're the same thing. Okay, bless you. Okay, so is cosine the x value or the y value? Good. Seeing a lot of x values. Excellent. Okay, so I'm going to go to my x value and I'm going to find every time, the 2 times when secant is negative square root of 2 over 2. So I'm going to find that here. Okay, I'm going to erase on here. You guys are looking for them while I'm erasing my scribbles. Okay, so we're looking for the x to be negative square root of 2 over 2. Here's one, 3 pi over 4. Here's another one, 5 pi over 4. That should be the last one. So 3 pi over 4, 5 pi over 4 would be my solutions to that one. Okay. I'm going to ignore the instructions on this one. We're not going to do this part, okay? In AP Calculus, we never go more than 1 revolution around, so that's where we're going to head, okay? Because that's what's important right now. Okay, we're going to dip our toe into this. We're going to try 7, we're going to try 8, and we're going to be done for the day, okay? That doesn't mean that we're done for the day. It means you're going to take a 2-minute break if you're a few minute break if you're at home, and if you're here, then you're going to work on your work. You're missing homework, right? Because I'm not assigning new homework. That's my gift to you this weekend. All right, so I'm going to just solve this equation. We're going to treat the trig like it's an x, like it's a variable, okay? So what's the first thing, if that's a variable, what's the first thing we would do? What do you guys think we should do first to solve like a 2-step equation here? What do you guys think? Pretend this is a big fat x. What would I do? Move the 1. Yeah, how do I move the 1? Yeah, we're going to add it. Good job. I'm waiting on my chat. Okay, I've seen isolate the variable. I'm seeing move the 1, inverse operations. We've got some really good vocabulary going on in the chat. Nice work. All right, we're going to add the 1. So I'm going to have 2. I'm not going to really call it an x. I'm going to call it sine x equals 1. Okay. All right. What do you think I need to do next? Yeah, good job. All right, I'm waiting on my chat. What do you guys think we should do next? What's the next thing? All right, I'm seeing divide the twos. Perfect. I'm not going to write the divide symbol underneath, right? We're in Algebra 2 with trig. We're a little bit more sophisticated than that. So you got to feel like an elite mathematician when you are, right? Okay, you don't. If you really need to show the steps, show the steps. Isn't that the exact same thing now that we were doing up here, right? It's the same as example 5 and example 3. Just we have a 1/2 instead of a square to 3/2. We basically just took a couple of extra steps to get to what we were solving before on our unit circle. Okay, so now assign the x value or the y value on the unit circle. Good job in the room. Waiting on my chat. Okay, good job. Y value. So I'm going to walk around my unit circle and I'm going to find everywhere where the y value is positive 1/2. I'm going to dig up that unit circle one more time. So y value positive 1/2, pi over 6. I'm going to keep going. If I know the secret, y value positive 1/2, 5 pi over 6. So pi over 6, 5 pi over 6 would be my answer to that one. Okay. Pi over 6, 5 pi over 6. So all we did was we took one more baby step. Okay. So here's what I want you to do. I'll shine the unit circle back up there in case you need it. But I want you guys to try example 8 on your own. It's identical to what we just did. Okay. So everybody try 8 on your own for just a minute. Okay. Look up at what I wrote. I wrote it kind of over here in the corner. Okay. If you agree with me, put a smiley face in the chat. If you don't agree with me, put a sad face in the chat. Okay. Cole just says it out loud. I think that's great. Matthew didn't turn his camera off today. He usually has his camera on.
Sorry.
Oh, there he is.
I was in the bathroom. What did I miss?
Thanks for sharing. You'll have to catch it later on YouTube. Okay. I got some smiley faces in the chat. Seems like we got the answer that is the same. Okay. All right. We are going to so we got to reverse this, right? We got to find everywhere where the x value is positive 1/2. So here's a positive 1/2 here. So I'm thinking pi over 3. And then another positive 1/2 right here at 5 pi over 3. Okay. All right. That's where we're going to stop today. I think we need our joke of the day, though, right? Andy found a joke about Fridays today. So he found it was pretty good. And we'll see. We'll see if he does good. He does all his work today.